Hey guys, welcome back to Genius Learning. So Physics 1, Exam 1 review. We have another projectile motion problem. This one kind of involved. You got this person throwing a ball, right? In its parabolic shape. You got this wall that's 5 meters tall. The length from the person to the wall is 14 meters. The size of the person is 1.6 meters, and exactly where he threw it from the horizontal angle and the velocity initial is theta equal 56 degrees. Okay, velocity initial is not given, and how far past the fence is not given also. Okay, and so all those things in place. Our first question is, I'm not gonna write it out, but what is the minimum initial speed that the ball must have as it leaves your hand in order to clear the top of the fence? Okay, so it says what minimum initial speed. Right there I would stop and I would say, okay, what minimum initial speed? Speed velocity, right? So I'm gonna just put this and I'm gonna say, hey, that's what they're looking for. Initial velocity needed, right? And minimum. As the ball leaves the hand, which is up here, right, at 1.6 meters up and 56 degrees to the horizontal, above the horizontal, and to clear the top of the fence, so to clear this back piece here. Okay, so let's approach it how we approach the other ones. What formulas do we know, or what things do we know? Okay, we want to know if we can clear this part of the fence, or like the fence period. Okay, this direction is in the y, so maybe I can start off with the formula for displacement in the y. I don't know, let's just write it out. So we got delta y is equal to v initial in the y times time minus 1/2 g t squared. Okay, so I'm just gonna hold on to this for a second. And I know that it has to at least get here and, you know, have this involved if we're gonna talk about to the fence. Okay, so the height of the fence to clear it, but to the fence is important. And so we also need displacement in the x. And that's v initial in the x times time. So I just have those two, and we're gonna see if they're useful now or how we can use them, etc. So let's see. We don't have the time, right? And so that's the common factor in both of them that we don't have. And so let's do something. All right, let's use one of them to solve for time and plug it into the other one. We've done this in previous problems, and something you should get used to at least thinking about, because if you don't have certain values, you're gonna have to make a system of equations. All right, so let's first of all, I want to rewrite this v initial y and v initial x into what they really look like. All right, so they're in disguise. I want the angles exposed. All right, so we got, and I also want this delta y and delta x to be exposed. For now, let's see. I'm gonna do this one first. So I'm gonna do y2 minus y1 is equal to velocity initial in the y is equal to v initial sine theta. Right, you should know that already. Times time minus 1/2 g t squared. So I rewrote this in a more explicit form, exposing these two. And this one here, I'm just gonna keep the delta x for now. And this v initial in the x changes to v initial cosine theta and still times time. So I just rewrote them, okay? And like I said before, time we don't have in either one of them. And so that's a problem. But if we solve one of them for time right? Get an expression, put that expression into the other one, we might be able to do stuff. What the hell am I talking about? Let's find out. Let's solve displacement in the x for time because it's smaller and usually this is the move. So I'm gonna put delta x over velocity initial cosine theta equal to t, right? Just divide it out, v initial cosine to the other side, and I have this expression for time. Now let's put that into this equation. Okay, so I'm gonna put, I'm just gonna rewrite the left side, y2 minus y1, v initial sine theta. Here I have delta x, v naught cosine theta, right? That's what the t was solved for, and then 1/2 g, and here I have delta x over v naught cosine theta, right? And that is squared. So, okay, so then, yeah, so then this is still just the y, right? We just replaced the t's with what we solved for here. Now let's I think, yeah, so let's cancel things out. Let's see how it looks. Okay, before we start plugging in numbers. So y2 minus y1, the velocity initial and velocity initial on top. So this cancels with the bottom one. And I'm not gonna write tangent, or do I wanna write tangent? I don't wanna do anything crazy here. So let's just put sine of theta times delta x. All of that is over cosine of theta, right? We just move this over and multiply all this. So sine times that, and you still have cosine on the bottom. Then you have minus, and let's see what we're left with on the other side. We have everything in here. Okay, so we have 1/2 g. We still have delta x over velocity initial cosine theta, and all of that is squared. All right, perfect. What do we have? We have the angle. We have velocity. We don't have velocity initial. We have delta x, which is 14, because that's to the fence. Gravity we have, and the angle. Over here, y final, y initial. So y initial is where it started from. It started from his height, 1.6. So this here is gonna be negative 1.6, okay? And then y final needs to be at least a minimum of 5 meters in order to clear the fence. Okay, so I'm gonna repeat that because that's where everybody makes the mistakes. All right, so you need to find the minimum initial speed that the ball must have in order to clear the fence. Okay, so what velocity initial? Here, when we're doing the differences in the initial y and the final y, initially the ball started here at a height of 1.6, okay, and then it's gonna go to a final height that we require. We require it because we're looking for the minimum speed that it'll take to cover 5 meters. Okay, so that's why we put 5 here, because that's at least the minimum that it needs to go. If it goes any shorter than that, it's gonna hit it. Okay, and we don't need any higher because we're just looking for the bare minimum. So we assign that, and now we got equals sine of 56 on top, delta x all the way to the fence is 14 meters, cosine of 56 on the bottom. Over here we have 1/2 times 9.8, and in parentheses we have 14 over velocity initial we don't have, and cosine of 56. Everything is still squared. Okay, so for those of you that are not algebra ninjas, this is a nightmare to get correct and solve for V initial. Okay, I don't want to do it in like 1 or 2 moves, just so that way it's clear, but I'm gonna try to move through it quickly. I don't want to have to calculate everything out. So I'm gonna move this to the other side. Okay, so let's see. I'm gonna still have 5 minus 1.6. This I'm gonna move to the other side, so it's gonna be minus sine of 56 times 14 cosine of 56. Right, now I'm left with this on the right side, so I'm gonna multiply the top by 2. So I'm gonna multiply everything here by 2, and I'm gonna divide by 9.8. Right, I'm gonna throw the negative sign on this side. What else? So now I have 14 V initial cosine of 56 still left on the other side. And I know I'm moving kind of fast, but this literally is just algebra, so you guys can practice this stuff on your own paper, however you like to do it. So I usually don't like to do this, but I would calculate it all out and probably just do numbers, smaller numbers. So now I need to get this V initial squared from the bottom to the top. So I'm just gonna make this very ugly looking. All right, I'm gonna put this V initial squared on this side, and I'm gonna put this whole thing underneath. Okay, so V initial squared, right, is gonna go to the top of this side, and all of this is gonna go on the bottom. I'm still gonna have the 14 squared. I'm still gonna have the cosine of 56, right, and that's gonna be squared, those two things. Velocity initial squared went to the other side, and now I'm gonna put in brackets, this entire thing just goes to the bottom. I'm just gonna write a big 1 over all of this. It's just a really crappy way of doing a lot of algebra, but I'm confident that this is very simple to figure out, and a lot easier ways. I'm just being a little bit lazy. Okay, put all this in the calculator. Actually, sorry, this is squared, so now we can square root both sides, right? Square root this side, we'll get rid of that 2, and now we have velocity initial is equal to all of this. Okay, put that into the calculator. You should get velocity initial is 13.40 meters per second. So this is the velocity initial minimum needed. So minimum speed needed, right, to clear the 5-meter fence right there. Okay, so let's put a little important box around it. Now let's do part B. Okay, so part B, we have so with V initial from part A, right, what horizontal distance beyond the fence will the ball land on the ground? So what horizontal distance beyond the fence will the ball land? So now that you cleared the fence, where is it going to land, and how far is that distance from the fence? Okay, so let's think about it. And also, I'm running out of room. Let me get paper. Okay. So we need to find this horizontal distance. Okay, so that makes me already think of, I need to have velocity. I need to have this equation here ready because I'm gonna need it. And do I have the time that corresponds to this distance? No, I only have the time expression that corresponded to this distance, which I guess I can use again, but I think that there's an easier way. So let's take a look at v initial in the y direction. Okay, so let's take a look at this equation here. All right, we have all the values. Let me write it here so it can be clear. Delta y v initial in the y times time minus 1/2 g t squared. All right, so sometimes navigating where to start from is kind of like a puzzle, and there's a couple ways, but you know, if you're gonna just do this way, it's fine, or you can also think of a different way, but that's how, you know, that's how the more complicated problems are. Just, you know, you got to go around things. So we're going to look at this one. We need this, right? We need this distance. We're going to need this equation, but we don't have the time that the ball is going to land all the way over here. Okay, we only express time in this thing and plugged it into y, but maybe we don't need to do this again, because if you take a look here now, right, we have some of these values. Okay, v initial in the y, if you recall, which you need to recall, v initial in the y is equal to v initial sine of theta. Okay, and we have those values. We have v initial and we have sine of theta now. I mean, now we have v initial and we already had sine of theta, so this is equal to 13.40 times sine of 56. So v initial in the y is 11.1 meters per second. Okay, so we have this value now. Before we didn't have that value, right? When we started off this thing. But now we can calculate it and we have it. So now let's take a look at this again and see what we have. All right, we have the left side. He starts off, the y initial is his height, so y2 minus y1, right? So y1, so, okay, I just wanted to write that here, right? So now separate, something very separate, y2 minus y1. y1 is where he's starting to throw it from, so negative 1.6 goes there. And y2 is gonna be where it lands, on the ground. So that's 0, okay? So I'm just starting this right here. Now I'm putting equals to this thing, which we calculated there, 11.1, okay? We don't know the time yet. Minus 1/2 gravity we know, and we don't have the time here either. But if you take a look and you recall the last problem that we did, or have seen a similar one that I've done, we have a quadratic. Okay, you have to be able to look out for those, because sometimes they're gonna be in these problems, which is what makes them a little more complicated. Let's rearrange this. Okay, so we're gonna have, I'm gonna rearrange it to have everything equal to 0. And I'm gonna put this as positive. I'm gonna move this to the other side of the equation. So I'm gonna have 1/2 9.8 t squared. I'm gonna move this to the other side of the equation. So it's negative 1.1 t. And this stays on that side of the equation, 1.6. Everything is equal to 0. So now it's perfect, because you can see that we have t squared, we have t, and we have a constant. All right, so this is A, this is B, and this is C. Okay, as much as I hate the quadratic formula, at least now we have, you know, a way to find time. And so right here, I'm just gonna write the quadratic formula. Negative, so t, so I'm gonna write t is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Okay, so I expect this negative 11.1 to be here, you know, I'm just go plugging it in. You should be familiar with the quadratic formula and like plugging the stuff in. This video I want to kind of move a little quicker, so once you solve for t, I'm gonna put this paper over here because I ran out of space. So I'm gonna continue up here. Yeah, sideways, okay. So I'm gonna continue this up here. And after plugging everything in, I had t, I'll just write out the numbers at least. 11.1 plus or minus the square root of 11.1 squared minus 4.9, and negative 1.6. Everything over 4.9. Plugging that into the calculator, we're gonna get 2.4 seconds. You pick the positive value. So perfect. So this 2.4 seconds represents how much time it takes from here all the way to the end now. Okay, so now that we have that, let's revisit this equation. Remember that we looked at this one. We said we didn't have the time, and so we used this one in order to find out the time. Now we're back here, and let's plug stuff in. We have delta x, okay, is equal to, let's rewrite this like that. So we have v initial cosine of theta times time. All right, plugging in the values, we're gonna get delta x is equal to, initial velocity is 13.4, which we calculated. And then we have cosine of 56, and the time it takes for that is 2.4 seconds. All right, so putting that in the calculator, we're gonna get 17.9 meters. Now, you may think, this is great, we found the answer, awesome, but this is where the students make mistakes. So I'm just trying to give you like, where if I were to give a test, this is where I would expect you to make a mistake. This is where, you know, I try to challenge your knowledge. This distance here, right, represents the entire distance here. How do we know that? Because the time we used, right, started from here and ended all the way over here. And so it makes sense that if we're gonna use that same time in this equation, that the distance we're gonna get starts from here and ends all the way there too. Okay, so that should make sense, that the time we calculated is from here all the way to the end. If we plug that into an equation that has displacement, then the displacement is also gonna represent where we started from at the time and all the way over here. Okay, and all we're looking for is past the fence. And so if you stopped here, you know, it's good, but it's, you know, it's not gonna be fully right. The last step is to subtract this length here, because we calculated right now the entirety of from here to here. Subtracting this out will just leave us with this part. And so the last step, right, is gonna be 17.9, which is the whole length of this thing, minus 14, which is just this, so subtract that out. And then we're gonna be left with 3.98 meters. And if you stop here, then that is fantastic because you're done. Okay, so this is the length of this here. This is 3.98 meters from there to there. All right, so things to watch out for, things to do when you first read the question. Write down what the final answer, what the final thing is that they want. You see, like, this is the first thing I read, and so like that is exactly what our goal is gonna go towards. Then write down relevant equations that you think are gonna be needed. we needed to find how high or like how much it needs to clear this. So, you know, the Y1 displacement is perfect. How far past the fence, and so displacement in the X is perfect. Okay, and then, you know, doing a couple trickeries and a couple of hibbity hooblas here, and we get velocity initial. The algebra is not that hard, but like, I just didn't want to have to go through it all again, you know. And for part B, calculating just this space here, we look at what we found in the first part and use that, so that way we can solve for this here, knowing that V initial in the Y really looks like this. We found V initial, we know the theta, so now we have this, and then quadratic, we find time, right? We plug it into displacement, and then think for a second. Stop and think, does this seem correct? Also, because you have 14 here, you know, if it just cleared the fence, it's 5 feet. Do you think it's gonna go 17 feet all the way to the right? More than the distance covered in the beginning. That already doesn't make sense, okay? But look back at the time that you used. The time starts from here, it goes all the way to the end. And so it makes sense that this is the whole thing. Subtract it from 14, and you're gonna get just the remaining distance here. Okay, hope that was helpful, guys. Thank you for watching.